good day to you. This is the first episode of our YouTube channel, Research to Reality. On this program, today we are going to talk about the significance of research becomes a reality in the era of artificial intelligence. Our guest today is Dr. Lakshitha Pahalagedara. Let's look at his profile to find out more about him. Dr. Lakshitha Pahalagedara currently serves as the Dean, Faculty of Postgraduate Studies and Research, Sri Lanka Technology Campus, and as a member of the Board of Study of the Postgraduate Institute of Science at the University of Peradeniya. He is a strategic innovation leader, a material scientist, and a researcher with over 14 years of experience in academic and industrial research and development. He obtained his PhD from the University of Connecticut, USA. Dr. Pahalagedara has worked with world-renowned companies such as ExxonMobil, Corning Incorporated, and the US Department of Energy during his postgraduate studies. He also worked as a senior manager at the Sri Lanka Institute of Nanotechnology and is also the inventor of 2 US patents. Welcome to the program, Doctor.
Thank you, Udini.
Let's start off with a brief overview of your present research activities, Doctor.
Well, it started, all my research life began when I was at University of Connecticut doing my PhD. At the time, I started with fundamental research. My first research paper was on a very fundamental matter in chemistry. And then I got the opportunity to work with some private companies such as ExxonMobil and Corning Incorporated. There I got the opportunity to work on applied research. So that's where I learned my first lesson on research and how to convert fundamental research into applied research so that many people or the general public can get the real benefit out of it. And then soon after my PhD, I decided to come back to Sri Lanka, and I joined Sri Lanka Institute of Nanotechnology as a scientist, and I started working on materials science, materials application in wearables and energy side. And after 2 years, I got the opportunity to take over the business development and technology transfer divisions. So I started as the head of business development, and that was a big challenge for me because I was a scientist, I was a researcher who had no real experience in doing business. But then I thought I took a couple of days before I give my decision. And then I realized that if I want to make a real impact in research, that's of course why I came back to Sri Lanka. I should take over this role because that is a position which connects researchers with the industry. So if you really believe in research, if you really believe in innovations, I thought that it would be a very good opportunity for me to do something which can create an impact. So that was a big challenge from the very beginning because, as you know, scientists and researchers, they speak their own language, and the industries, they speak their language with numbers, rupees and cents. So it was a big challenge to connect these two sets of people. So then with time, I worked as the head of business development for about 5 years. And at the same time, I managed my research work as well. One of my students graduated with a PhD during that time with about 4 research papers. And I built up a good network. And then I believe that I could influence some of the industry leaders to invest in research and then get the real benefit out of it. So at Sri Lanka Institute of Nanotechnology, or SLINTech, which is the pioneer research institute in the country, I was able to do research in material science, and then I did a lot of wearable applications and then energy applications. So after 5 years, after 8 years being at SLINTech, then I decided that I can create more impact if I join the academia, but in a different way, not in the typical way. Because all my career decisions are driven by the impact that I can create. Then I got the opportunity to speak to the president of Sri Lanka Technology Campus at that time. And what I pitched was how to use research for the benefit of the students, the lecturers, and the entire community or the entire country. Because I saw that at SLTC there's a great opportunity, because there were researchers who work in different areas. There were researchers who do agricultural research. There are researchers who work on engineering aspects, civil engineering, and then IoT, AI-related stuff, and electronics. So I thought that this would be a good opportunity, because everybody is in a close proximity. And in the future, the research will not be segregated or kept in a silo. It's all about collaborations. So I thought that this is a very good place to create good collaborations and then connect that research with the industry. So then I took over the position as the associate dean of the faculty, and then later I became the dean. So now I'm working on both the postgraduate studies aspects as well as the research aspects in the university. At the moment, we have 12 research groups in the university. So maybe later I will explain how what I have initiated at the university and what my future plans are.
Thank you. Well, AI is a trending topic spoken about a lot nationally and internationally. Would you mind talking a little bit about relationship between AI and research?
Sure. A very good question. We all know that we are in the midst of the fourth industrial revolution, or 4IR, as we all know. And AI plays a big role in this fourth industrial revolution. It's when you speak about the fourth industrial revolution, it's not only about AI. There are some other factors as well, such as biotechnology, nanotechnology, cryptocurrency. But I feel that AI has done the biggest impact in people's lives, and it has changed their lifestyle drastically. So the reason is because if you consider all the industrial revolutions that we have had since the first one, where the steam engine was introduced, and then later on with the second and third industrial revolutions, it destructively changed people's lifestyles. So AI is doing nothing more than that, but it has a bigger impact with the very high population that we have, and also it has integrated into the human side really well compared to automation and the steam engine and the computer or internet. Compared to all these things, AI has integrated into the human lifestyle, or the human aspect, has touched the human aspect. So now we know that there are AI or AI-driven artists, there are singers, there are painters, so which we thought that never would be replaced by the technology. We all thought that the creative side or the creative jobs will never be replaced by technology. But AI has changed it. Even when it comes to research and development, AI can quickly do analysis, because AI is all about connectivity and data analytics. So that's about that's how it analyzes the previous data in a very short time, and then it can come up with a nice integrated solution or suggestions with the past experiences, and it can rationalize that really well. AI plays a huge role, and let's see how it can affect the research that we do, because we all know that we do a lot of research in the world, especially in the developed countries. A lot of research are being happening. What I feel is now every research that we do has something to do with AI, because AI has integrated into the lifestyle that much. So whatever we come up with in the future as an innovation has to be coupled with AI. You talk about agriculture, food, everything, pharmaceuticals, biotechnology, everything has to be coupled with AI. So if someone is doing research and say that I don't want to get AI involved in my research, I don't think that it will become a innovation any day. So if it is to become an innovation, it has to couple with AI. So AI has that much impact on research and development.
Well, moving to another connected topic, Doctor. Security of the water, energy, food nexus has become a global concern. This issue has intensified by climate change. Could you please speak a little bit about that, how we can overcome these issues through successful and productive research?
Well, we all know that the world population is increasing in a very high rate, and it will reach 10 billion very soon. So that means we have to feed all the mouths, right? And apart from that, we have animals and other living beings. So we have to create a lot of food. That's the first requirement or the first need. So food is very, very important factor. And then we need to have clean water. So these are basic needs. And also, when people live, they want to have energy, right? Energy has become the other most important thing. So food, water, energy nexus will play a crucial role, and how we address the issues within this nexus will decide the future of the mankind. So let's start with food. Now, we know that we have to produce a lot of food in the future. But on the other side, we have some concerns in the area of land that we have to produce, to cultivate. And also there are some climate issues. And also we have to make sure that everybody gets good nutrients and they get a balanced diet. So research has to play a crucial role there. For example, now food or the agriculture works hand in hand with the climate change. Because of the bad agricultural practices that we have had in the past, we have caused the climate to have bad effects because we have used a lot of chemicals, a lot of pesticides, and also we have done deforestation. And as a result, climate or the environment has answered in a very specific way, where we mainly the temperature, global temperature increases, and then there are floods, there are some unexpected climate changes, and all these things. So that affects the food production. So we have to have a balance. We have to make sure how we produce a large amount of food with high nutrient content with the least effect to the environment. So companies such as BASF and other food or the agriculture related companies, they have come up with a lot of patents, a lot of innovations. For example, I'll take the word urea, which was a buzzword a couple of years ago. Now everybody thinks why we ban urea. There's nothing wrong with urea when it comes to the chemical aspects. The problem is when we put urea, 1 kilo of urea, only 28% gets absorbed by the paddy plants. So that means the rest, or 720 grams out of 1 kilo, gets evaporated, or it goes to the water bodies that we have, and then it creates unnecessary problems in the water bodies. So the solution should be not to ban urea, because if urea was not there, the world population will be halved. Because urea, we generate urea through a process called Haber-Bosch process. Another greatest innovations in the entire mankind. Two people named Haber and Bosch came up with a scaled up production of ammonia using nitrogen and hydrogen, and then this ammonia is used to produce urea. So that was a very important discovery that was made. So there's nothing wrong with that. It's all about how we manage it. Now, the farmer thinks that if you put a large amount of urea, you get a better yield. But that's not the case. So we have to think about the ways that we can manage the fertilizer in such a way that a larger portion gets absorbed by the plant. So there are innovations, even in Sri Lanka. At Slintech, there was an innovation where they came up with a slow-release fertilizer, where a nanoparticle is coated with urea molecules. So when you put urea molecules, urea into the plant, only a portion gets absorbed by the plant depending on the rate of the absorption, and the rest remains on the soil. So that is called a slow release fertilizer, because the urea molecules are not directly released to the environment. They are attached to a nanoparticle. So with this invention, they were able to manage the urea absorption or urea wastage to a very low value. So in normal case, only 28% gets absorbed, but with this, about 48% gets absorbed, and they got the United States patent as well, and they are producing it in large scale at the moment. So these type of inventions are happening all over the world, and that needs to be done. And then you have to think about the post-harvest loss. That's another problem that we have. For example, even in, I don't want to mention the supermarket chain name, one supermarket chain, their cost is about 40 million per month because of post-harvest loss. So which we can manage through technology. Many countries, they manage it. They use less energy, and then they preserve the food, and also they lower the ripening effect when the fruit is in the supermarket by using absorbers. So there are many technologies that people have come up with in order to reduce the post-harvest loss. So that's again a massive problem we have. So that's about the food part. And then if you move on to the water part, the other important thing, people have no access to, many people have no access to clean water. Even in Sri Lanka, we are a country blessed with a lot of rain, but still during the drought season, people who get their water from the wells, they have some problems, because there are some the ions, the concentration goes up during the dry season or during the drought, because you have less amount of water, so the concentration goes up. So that's a problem. And if you think about countries in Africa or in the Middle East, they lack clean water. So the best solution is to desalinate seawater. So there are some technologies which can remove the ions in the seawater, and then you can convert it into a usable, drinkable water. Or you can do the same for brackish water, and then you will be able to use that for desert agriculture. Because the countries in the Middle East, they if they can get water from the sea and clean it and then use it for agriculture, it is a very attractive and a very workable model, which they have already started working on. And also, we know that there's wastewater, which comes out from the industrial zones. And so there are technologies to clean these wastewater. So these are the things that we can do in the water aspect. And also, if you can harness moisture and then get it as water, then still people can use it. So there are technologies which can do that. So, and if you move on to the energy side, the other important side, because we all have, as a country, we have a lot of experience in about the energy crisis. So the good thing is the world, the rest of the world, they don't know what the crisis would be, and we know how it would affect our lifestyle. But everybody will face this problem, not only Sri Lanka. Every country in the world will face this problem. The developed country will face it sooner because they use a lot of energy for production, and it will in turn affect countries like us. So, but the scientists and engineers, they have seen this problem long time back, and then they have taken up some initiatives, and they have started doing research. And we use a lot of renewable energy more than we think in the developed countries. And even in Sri Lanka, we have wind energy plants and the solar energy plants. So the world, in that aspect, I think the world is doing pretty good at the moment, how to harness the renewable energy. Then the problem is how to store it. So because you harness sunlight near the equator, because you get a lot of sunlight in the countries like us, and towards the poles, you get a lot of wind. So you harness wind energy. But the problem is it doesn't match the demand, because you can never predict the pattern for renewable energy production. But the demand is always pretty much stable. But the problem is then how you integrate that into the system or into the grid, because it's not practical to get energy from the wind towards the poles into the grid. Then you have to have very large cables, which some countries do at the moment. But the best way is to store that in a battery. So that's what we also do. We harness during the daytime, and then we store that in a battery and then use it in the night where the peak is, because yes, in a country like us, our peak is in between 7 p.m. and 10 p.m. We don't do much production during the daytime. So our duck curve, that's called the duck curve, the energy demand, or in our case, the backside is, the curve goes up because towards the night, we use a lot of energy to watch TV. The problem is, anyway, we have to store this energy. So the best way is to store in a lithium-ion battery. That's the current technology that we have. But then the problem comes where it's expensive, because lithium is not readily available. And we will run out of lithium in the near future. There will be a very high demand. And also, when you mine lithium, not only lithium, in these batteries you need other elements such as cobalt, copper, nickel. You do a lot of environmental damage. It has a very large effect which we don't realize at the moment. Even though we say it's renewable, it's sustainable, it's not really sustainable in some aspects, because you mine, the mines are huge. They are diameters miles, given in miles. So that's also a problem. So now people are looking at cheaper, more sustainable ways of storing energy. In that case, you can use sodium-ion batteries. That's one aspect. And there's another type of battery called flow batteries, where you use more environmentally benign materials and also cheaper materials to store energy. And another good aspect that we can look at is hydrogen energy, because hydrogen is considered as one of the purest forms of energy. But how do you get hydrogen? We all know water is made up of hydrogen and oxygen atoms. One oxygen atom together with two hydrogen atoms makes one water molecule. So if you split it, you can get oxygen gas and hydrogen gas. you mainly do it through a process called electrolysis. So you use electricity to split the water molecule into oxygen and hydrogen. Then hydrogen can be used in for energy. For example, in my case, one of my most cited papers, which was published in a very high impact factor journal, is on water splitting and getting hydrogen. So I worked on catalyst material. We all know catalysts can lower the activation energy. So with a lower energy, you'll be able to do the reaction. So this was on that. And then you get hydrogen gas, and then hydrogen gas can be used as an energy source. In most of the developed countries, they run buses with hydrogen at the moment. So the next target is to use that in ships and also in aeroplanes, where you use a lot of energy, a lot of fossil fuels. So that's, and even in the hydrogen, there are different types of hydrogen. There's one thing called green hydrogen. So for that, you get this electricity for electrolysis through renewable energy. Then it's called green hydrogen. And there's another form of hydrogen that's called pink hydrogen, and then gray hydrogen. It depends on the source of energy that you get to split water molecule. So hydrogen, in the future, hydrogen energy will play a crucial role even in Sri Lanka. So that's something that we can be happy about, because we have enough water, we are an island, and if we can implement this, that would be a good, a cheaper energy source in the future. So some people question whether this is cheap enough or not. But when you consider every technology, even the computer, at the very beginning it was very expensive, but when you scale it up, then the cost goes down. So we have a lot of hopes in hydrogen energy in the future. So that's about the energy, water and food nexus, and how innovations and research can play a crucial role there.
Very interesting, Doctor. What are the challenges or obstacles do you think that individuals and Sri Lanka as a country encounters in relation to research?
Well, another important question. So whenever you get that question, what you think about is the funding. Because everybody complains that we don't have enough funding. At the moment, even the state universities don't get much funding for research. It's a very small percentage from the GDP. Then on the other hand, there's another factor that the policymakers can question about. That's what is the contribution of research to GDP. So that's a controversial problem. But more than funding, what I think is, now if you think about this innovation ecosystem, it starts with ideation. You come up with a good idea, and for that idea, you pitch the idea and you get funding. And then you do research and development. And then you create intellectual property. So then you have to make sure that this intellectual property has a high value. Then it can be commercialized through a technology transfer. So that's how researchers or research institutes or universities should get funds, because through technology transfer they can generate a lot of money, and then you can reinvest this money in research. You can get more facilities, more people. You can attract very good experts. At the same time, the researchers should also get incentivized. So that's an IP policy that we are working on at the moment. It starts with ideation. So funding comes next. So if you have, what I believe is, if you have good ideas, you will always get funds, especially from the private sector or the industry. And that's where we as a country have a problem, because I don't think that we don't define the problem statements really well. That's where the problem is, because we don't know what the exact problem is when it comes to a global issue. I have raised this up at several forums. Even during the last week, there was a forum where the State Minister of Higher Education attended, and even there I raised this up. because we have a lot of good researchers and we have fairly good facilities as well in the country. And but the problem is we don't know where the exact problem is when it comes to, for example, I'll take energy. We don't know what needs to be solved. So we come up with a very general research, thinking that someone else would take it and commercialize it. But there are because we have to understand that the entire world is working on these problems, especially on this food, water, energy nexus, and also on wearables, AI, IoT, everywhere. The entire world is doing research. It's not only us. So if an investor in the country needs to get a technology, he doesn't need to get it from Sri Lanka per se. He can take it, buy it from somewhere else if it is a good solution. So we are competing with not only the research groups within Sri Lanka, we are competing with the entire globe. So in that case, we have to identify where the exact problem is. For example, when it comes to a battery which store energy, the problem might be at a very small place. Everybody else might have solved all the other parts. So we don't have to work on the entire battery. Maybe we should be able to work on the battery, the electrode material, how to improve the electrode material. Thinking about the raw materials that we have as a country, because we have to think about that aspect as well. We know that we are blessed with some raw materials, some good raw materials. For example, graphite. We have been exporting graphite for a long period. For hundreds of years, we have been exporting graphite, which we found in pencil. But some complain that we don't even produce a pencil. But I feel that that's fine, because a pencil is a low value, high quantity material. So it's cheaper to get it from China rather than producing here. But what we can do is, rather than exporting graphite as it is, and we have high purity graphite, and more than that, we have graphite with large aspect ratio, that means large size. So graphite is just like a book, and if you peel this off and take these pages out, you call it graphene, which is a very strong material and which has a very high conductivity, electrical conductivity and thermal conductivity. So you can use it in many applications. For example, because of its strength, if you can mix it with concrete, you can come up with high strength concrete. So you can reduce the amount of cement that you use. And also, if you can use it in battery materials, in electrode materials, you can have high performance batteries. And also, you can incorporate it with wearable applications, in supercapacitors. There are many applications that we can work on. So we have to identify the exact point that we should work on. And also, when it comes to graphite, we can still make value-added graphite. For example, India gets our graphite, and then they make brake pads for Benz out of that graphite, which is a very high value final product. So we can work on that. We don't need to go towards graphene. Still, we can use graphite as it is and then add some value to that. So Sri Lanka as a country should focus on high value, high tech products, but we should not focus that much on the quantity, because we should not think about low value, high quantity products, because our labor is not cheap and our energy is expensive. We don't have much land. We don't have a chemical industry in the country. So what you should do is to come up with high value, high tech products. That's why, more than in any other country, in Sri Lanka, the researchers has a bigger role. The scientists and engineers has a bigger role to play if they want to revive the Sri Lankan economy, because they are the ones who can do the biggest impact on the economy. So if they can come up with high value products and high tech products using the locally available raw materials, we have EPA, the rock phosphate, we have thorium in monazite, we have ilmenite and titanium dioxide. If you can convert that into titanium metal, that has a lot of applications. That's a high value product. You can go for bone implantation. So these are the things that we should look at. But at the same time, we should have our radar around the globe and see what exactly needs to be done. it doesn't matter that we come up with a new thing or we publish a paper. It doesn't affect, it's good for your satisfaction. But with a paper, if you can come up with a new product or a process through which the entire country or the entire mankind get benefited, I think that would be your biggest satisfaction. So this is my personal view. I always believe that we should not get good ideas, partly because we are pretty much disconnected from the entire world. We don't have access to good journals, because then we have to ask from someone who stays in another country to download it and send it to us, because those are expensive. So if policymakers can work on that, and if the scientists have access to these journals, and also if they can have access to the industrial problems, because I always believe that there are a lot of expatriates, Sri Lankan expatriates, who got the benefit from the free education of the country. They learn from the taxpayers' money. There's no doubt in that, and they work in good companies, and they are willing to help us, such as NASA, Intel, Pfizer, you name it, General Motors, General Electrics. So if we can contact them, have a good discussion with them, if someone in the policymaker level should work on that, and then if they can make this connectivity between the Sri Lankan scientists and these people who see the real world and the real world problems, then our scientists would get all these problem statements, nice problem statements, so that they'll be able to work on that. So that's the problem we have as a country. More than funding, I think that's where the problem is.
Thank you. Before we wind up, I would like to ask you if you have any advice for the young generation with regard to research.
Yeah, so that's something that I currently work on within my capacity inside a university. I'm responsible for the entire research aspects taking place in the university, and also all the postgraduate studies which are taking place in the university. So starting with the research part, what we have started is we have started connecting with the industry and getting the real industry problems, so that we are trying to create this innovation ecosystem within the university, so that while they publish a paper, they'll be able to come up with a good innovation, good intellectual property, which they'll be able to transfer to an industry and then get money out of it. That's what I did during my PhD studies. I was able to publish a large amount of research papers. At the same time, I worked on industry projects. So I got a lot of experience through that, and then got patents as well. So this is something that any researcher can do. So that's one thing that we are working on. And the other thing is we just started an undergraduate research program, probably for the first time in the Sri Lankan university level. What we are trying to do is we are trying to get second year university students who like to do research, and then we take them through a certificate course where they start to learn from the research ethics, how to record research, how to do waste management, what are the safety issues, till IP creation, IP protection, and technology transfer and commercialization. And then we will assign them to the research groups that we have. So by the time they graduate, during that 2-3 years, they will get a lot of experience, and also they will be able to get a couple of publications under their name as well. So that's another thing that we work on. And apart from that, we are trying to connect with these international experts. For example, we started a webinar series, and the speaker of the first webinar, which will take place in the next week, is a senior manager from Boeing. Likewise, we are trying to get the exposure to the university students, so that they will learn what's happening in the outside world, and they will get an idea about the real world scenario. And on the postgraduate education side, we are now proposing a new research related postgraduate program, a MPhil and PhD program. We are currently working on it. the students will work on sustainable technologies, and they will get the support from the industry to come up with to do their research. So the entire research will work on sustainability, because in the future, this is my advice to the young generation, the next industrial revolution would be on sustainability. So earlier we came up with innovations, and some innovations were sustainable, some were not, because we didn't really have this problem when they came up with the coal-powered engine. They had no clue about the environmental damage that it would cause, or the carbon footprint that it would keep, because the problem was not there, because the population was small and it was not scaled up. But now we know all the repercussions of all these things. Now an innovation, to be an innovation, it has to be sustainable. Otherwise you can't call it an innovation. So my advice is, come up with good research and then try to commercialize it, try to transfer the technology to the industry so the general public would get the real benefit out of it, and make sure that it is sustainable.
And once again, thank you so much for sharing your knowledge and your perceptive ideas. That was Dr. Lakshitha Pahalagedara, the Dean of the Faculty of Postgraduate Studies and Research at Sri Lanka Technology Campus. We invite you to grow with us by joining us again next time. Have a good day. Until then, thank you.